Welcome to my YouTube channel Raise a Cat and myself Yash Mishra. Today we will be seeing different laws in thermodynamics. Okay. So what are the different types of laws in thermodynamics? We will see. So moving further in thermodynamics. Okay. So different laws. So first law is Zeroth Law of thermodynamics. Okay, so this is not counted, so but we will see Zeroth Law of thermodynamics. Okay, second is first law, second law, and third law in thermodynamics. Okay, so there are three laws in thermodynamics: first law, second law, and third law in thermodynamics. So in detail we will see what is first law, second law, and third law of the thermodynamics. Okay, so in the zeroth law, it states that if there are three bodies, suppose that there is a body A, this is second body which is B, and this is third body which is C. So suppose that there is a condition that A and B after some time they are in equilibrium. Okay, so there are A and B are in equilibrium, and B and C are also in equilibrium, okay, with each other. So if A and B are in equilibrium and B and C are in equilibrium, so from the first zeroth law of thermodynamics, the condition is both A and C will also be in equilibrium. Okay, so if A and B are in equilibrium, B and C are in equilibrium, and so A and C will also be in equilibrium. So if there is a equilibrium which is now they are in A and B with A and C, so there will also be a equilibrium with A and C. So from the zeroth law we can deduce that. Okay, so there are three systems which are in equilibrium with each other. So with the first and third also a equilibrium will be there from the zeroth law of thermodynamics. Okay, so let's see what is first law of thermodynamics. Okay, so first law of thermodynamics. Okay, so in the first law of thermodynamics it states that whatever the amount of, suppose that we have transferred a amount of energy E. Okay, so this is the heat which is supplied to the system. Okay, so there was a system which has been supplied this heat. So the amount of heat supplied will be equal to the change in the internal energy of the system. So this will increase the internal energy of the system. Okay, so, or if we are removing this heat from the system, so it is equal to the decrease in the internal energy or of the system. Either it will be a potential or the kinetic energy. So if we are giving heat, so it will be increased in the internal energy, and for the removal of this heat, the internal energy of the system will decrease. So it is stated by the first law of thermodynamics. dq is equal to du plus dw. Whatever we have supplied the heat is equal to the internal energy change but plus the work done. Okay, so work done is nothing else but the removal of the heat. Whatever will be the work done is equal to the decrease in the internal energy of the system. So if system will do the work, the internal energy will decrease. Okay, so from the first law, dq is equal to du plus dw. Okay. So let's see the second law of thermodynamics. Okay. Second law of thermodynamics. Okay, so from the second law of thermodynamics, it states that the entropy of the universe is always increasing. Entropy of universe is always increasing. Okay, so suppose that there is a process which has happened, so the entropy delta S of the system will always be positive, then only the work will be done. Okay, so suppose that there is a reaction which has happened, or some process which has happened, so it will always tend to increase the entropy of the universe. Okay, so universe entropy will increase for happening every process. Okay, so suppose that there is some process which has, in which the entropy is not increasing, so the process is not feasible or will not happen. Okay, so from the delta G we can also deduce the process will happen, delta G should be negative for the process to happen or not, and from this also we can deduce the entropy should always increase, then only the process will happen. Okay, so this is from the second law of thermodynamics, that the delta S is always positive. Okay, so let's see the third law of thermodynamics. Okay, so from the third law it states that the entropy of a perfectly crystalline substance is zero. Entropy of perfectly crystalline substance is zero. So from the third law of thermodynamics, the zero entropy is also defined. S is equals to 0 is defined from the third law of thermodynamics. Okay, so this is the standard which is defined from the third law of thermodynamics, that the entropy of a perfectly crystalline substance is 0. Okay, so this was for the third law of thermodynamics. It states that the entropy is 0 for a perfectly crystalline substance. So suppose that there is an example from these laws. Suppose that there is a substance which has a mass m, and this is a stone. Okay, and we are giving heat to the system. This heat is given. Okay, so from the first law we studied three laws: first law, second law, and third law in thermodynamics. Third law states that entropy is 0. So from the first law we learned that dq is equal to du plus dw. Okay, so whatever we will give the heat is equal to the internal energy change plus some work done. So internal energy is potential energy plus kinetic energy. Okay, so suppose that we have given heat and some internal energy change was there and some kinetic energy change was there. So if we supply heat, the kinetic energy of a stone will not increase. Kinetic energy will be equal to 0 only. So what we deduced that it will not fly or not having any kinetic energy, velocity will be 0. So the process we thought that the process, we thought that the kinetic energy will increase, potential energy will increase, kinetic energy will increase, but this process of increasing the kinetic energy is not feasible, because so the process is feasible or not will be told by this second law, that the entropy is positive or not, or the entropy is increasing or not. So the process is feasible or not is told by this second law, and whatever we will give will increase equal to the increase in the some energy of the system, or the definition of processes we can define from the first law, but the process will happen or not will be told by to us by the second law. Okay, so feasibility will be told by this second law of thermodynamics. Okay, so this was for the example of the laws in thermodynamics. Okay, thank you.